So today's project is swapping out this car battery in the bottom of my radio rack. So this car battery is float charged from the Alinco 330 power supply, so it's 32 amp power supply. Normally it just trickles into the battery kind of 10 amps when you first turn it on and very quickly tails off. So what's happened here is that the fuses on the battery, let's check. So this not enough light down here. This fuse here is in the incoming lead with Anderson power pole connectors that I plug into this lead that comes from the power supply. So I don't always leave it connected up. But what's happened is that normally there's a 10 amp fuse in there, and it kept blowing the 10 amps, and I didn't pick up straight away what was happening. But when you check with a voltmeter, one of the cells has collapsed in the battery and it's going down to 10 volts, so it's drawing a heck of a lot of inrush current before it's doing anything. Basically the battery's end of life. So we purchased this new battery to go in its place, and we're going to do that task now. As you can see, each end of the battery has a metal strip, and it's clearly marked plus and minus on the top there, and everything just kind of feeds off of there, totally fused. Anything that's not fused is that metal strip itself, because it's connected directly onto the post with the post clamp. So let's get on with the job. So to make things a bit easier, I have to access this nut here on both sides, but on the other side it's kind of recessed by this bar. I'm thinking I should probably undo this wing nut here, lift that away, and then just deal with the clamp separately. Not probably quite sure what to do. Or loosen the wing nut, rotate the bar a little bit, take the clamp off, and do the same on the other side, but making damn sure, or making very sure, that this metal plate doesn't come anywhere near anything on the other side, because we don't want like a 300 amp weld. Okay, so let's see how we can go. Oh, that's tight. Just persuade it a bit. There we go. All I was using was the flats there, just to use a bit of leverage on the wing nut just to start it off, but it's okay. So I'm screwing that up again so it doesn't go anywhere. That's pretty good access. I'm thinking when I do these back up I might use a socket. See how easy this is. Be easier if it was tighter. And it would be easier with a socket. As loose as you like. There we go, post removed. At this point we're probably safe. We'll just do the same with the other side. Ordinarily I would take the negative off first. I guess there's no real necessity in this situation, because we've not got an automotive body to worry about. Let's lift that plate off at the back now. She's not coming yet. A few more turns. switch is off. There's no power in the circuit here, so I can just let stuff drop to the metal baking dish, which I just got there just in case there's any acid leak. Mighty heavy. Oh. So that was an AC Delco 34A coming out there, 685 CCA, so charge crank amps. So 34A is the key bit of information on that battery. And what we got going back in, doesn't really matter because it doesn't get used. There we go, there's the info. Going back in, we've got a group 51, charge cranking amps, cold crank, that's what CCA, cold crank 450. Well, there's nothing much cold in here. Reserve capacity 70 minutes. Don't really say, but it's more than up to the job. So now, I'm noticing on this battery, negative terminal, positive terminal is marked on the actual plastic as well. For sure we've got to get them the right way around when we plug it back in. In actual fact, the orientation of this battery is the same as the one we took out there. So it's just going to slide straight back in, and we'll just install the same way we removed, I suppose. Simple as that. So here we go. My good goodness, their things are heavy. Removing the plastic cover would be more than useful. Slide straight on that way. Anyway, we're going to screw the things back up. Is the basis of this. Push it down quite firmly, finger tight, and then nip up with the wrench. That's finger tight. Now we're going to nip it up with a wrench. I'm going to use the flashlight here. It's actually a really easy replacement because it's literally just the clamp bolt and then rotating the kind of buzz bar arrangement that I've got into place and tightening it so you've got no loose connections. So that's more than tight enough. We'll rotate the buzz bar rearrangement back round to parallel again and tighten up the wing nut. It's going to be a two-handed job. One to hold the buzz bar, one to do the wing nut. Alright, and I'm going to use the wrench again, just the flats on the wrench on the edge of the wing nut. Just to get that little bit of extra torque, that's good. So negatives on, plastic cap off the positive, and we're going to do the same with the positive. At this stage things are going to start flashing around on the radios because they're used to being stuck on there permanently. Oh, there we go. That's in place. Finger tight and then nip up with a wrench. more than tight enough. And the same thing with the bus bar, we just rotate that into position. And now I'm going to nip up just one side. These are very thick wing nuts, so you can do this. I wouldn't do this on kind of thinner handled wing nuts. Now that's a very good connection right the way through. The battery's going to sit on the side there, and that's in position. Now, proof in the pudding, do the radios turn on? Turn on. Yes, the radio is on. And if we're in this radio, we can go to meter. It shows you there, it's sitting just above 12 volts. In actual fact, this little Yaesu radio here shows you 12.1 volts on the display when you turn it on. It's quite a handy voltmeter. So we're looking on here, and I'm going to connect in the Anderson power pole, the charging circuit, and we'll see how much it takes. So straight away there, you can see it's drawing a couple of amps, and now on the Icon radio you can see that sitting in the middle there. That's where it normally is, at about 13.8 volts, so that's good. So let's see. We have 13.1 volts, so it's working its way up, and I'm just going to leave that for a bit. The job's done.
So this video, if you like it, our video, comment down below a thumbs up.
Thanks for watching VA3SII. Bye.